It is indeed possible for a house constructed in 1969 to incorporate knob and tube wiring. Although this method of electrical wiring was predominantly employed in earlier periods, its utilization persisted in certain regions, including the United States, well into the 1960s. Knob and tube wiring consists of single insulated conductors supported by porcelain knobs and tubes. The knobs serve as anchor points securing the wires to framing members, while the tubes protect the wires as they pass through joists and studs. The installation method involves running individual wires, typically one for the hot conductor and another for the neutral conductor, separately through the building's structure. This differs significantly from modern cable wiring, such as non-metallic sheathed cable, often referred to as Romex, where multiple conductors are bundled together within a protective jacket. Several factors contributed to the continued use of knob and tube wiring during the mid-20th century. Firstly, existing electrical codes and regulations in some areas permitted its installation, particularly in renovations or extensions of existing systems. Secondly, the availability of materials and the familiarity of electricians with the technique played a role. Some electricians were simply more comfortable with knob and tube wiring, especially if they had been using it for many years. Thirdly, cost considerations could have been a factor in some cases, as knob and tube wiring may have been perceived as a more economical option compared to newer wiring methods at the time, although this wasn't always the case when considering the labor involved. However, there are several safety concerns associated with knob and tube wiring, especially in older installations. One of the primary risks is the deterioration of the insulation over time. The rubber or cloth insulation used in knob and tube wiring can become brittle and crack, exposing the bare conductors. This creates a potential for electrical shock and fire hazards. Another concern is the lack of a grounding conductor. Knob and tube wiring systems typically do not include a separate grounding wire, which is an essential safety feature in modern electrical systems. Without a grounding conductor, electrical faults can cause appliances and equipment to become energized, posing a shock hazard. Furthermore, modifications and extensions to knob and tube wiring systems can create hazardous conditions if not performed correctly. Improper splicing or connections can lead to overheating and arcing, increasing the risk of fire. It is also common to find knob and tube wiring covered with insulation, which is a serious fire hazard. The original design of knob and tube wiring relies on open air for heat dissipation, and covering it with insulation prevents this, leading to overheating. Given these safety concerns, it is generally recommended to have knob and tube wiring evaluated by a qualified electrician. If the wiring is found to be in poor condition or does not meet current safety standards, it may be necessary to replace it with a modern wiring system. Replacing knob and tube wiring can be a significant undertaking, but it is an important investment in the safety of your home. Modern wiring systems offer improved insulation, grounding, and overall safety features. When replacing knob and tube wiring, it is essential to follow all applicable electrical codes and regulations. A licensed electrician can ensure that the new wiring is installed correctly and safely. In some cases, it may be possible to leave some knob and tube wiring in place, especially if it is in good condition and meets current safety standards. However, it is still advisable to have it inspected regularly and to address any potential issues promptly. Additionally, it's important to ensure that any existing knob and tube wiring is properly protected and not subject to physical damage. Consider having a qualified electrician inspect the electrical system thoroughly. They can assess the condition of the wiring, identify any potential hazards, and recommend appropriate solutions. Remember that working with electricity can be dangerous, and it is always best to leave electrical work to qualified professionals. When assessing knob and tube wiring, an electrician will typically look for several key indicators of its condition. Firstly, they will examine the insulation for signs of cracking, brittleness, or deterioration. Any exposed conductors will be a cause for concern. Secondly, they will check the connections and splices to ensure that they are properly made and secure. Loose or corroded connections can lead to overheating and arcing. Thirdly, they will inspect the porcelain knobs and tubes for any damage or signs of wear. Damaged knobs or tubes may indicate that the wiring is under stress or has been improperly installed. Fourthly, they will look for any signs of overloading, such as melted insulation or discolored wiring. Overloading can occur when too many devices are connected to a circuit, causing the wiring to overheat. In addition to a visual inspection, an electrician may also use testing equipment to assess the electrical integrity of the wiring. This may include testing for continuity, insulation resistance, and voltage drop. Continuity testing verifies that the wiring is properly connected and that there are no breaks in the circuit. Insulation resistance testing measures the ability of the insulation to prevent current leakage. Voltage drop testing assesses the amount of voltage lost along a circuit, which can indicate undersized wiring or poor connections. If knob and tube wiring is present, it is important to avoid certain practices that can increase the risk of electrical hazards. Firstly, do not cover the wiring with insulation. As mentioned earlier, this can prevent heat dissipation and lead to overheating. Secondly, do not overload circuits by plugging in too many devices. This can cause the wiring to overheat and potentially start to fire. Thirdly, do not attempt to repair or modify knob and tube wiring yourself unless you are a qualified electrician. Improper repairs can create dangerous conditions. Fourthly, do not ignore any signs of electrical problems such as flickering lights, sparking outlets, or burning smells. These may indicate underlying wiring issues that need to be addressed promptly. Instead of focusing on knob and tube wiring only, it's useful to provide a broader explanation of electrical wiring methods in residential buildings, including the more modern non-metallic sheet cable or NM cable, often referred to as Romex. NM cable consists of two or more insulated conductors enclosed within a non-metallic outer sheath. It is widely used for branch circuits, which supply power to outlets, lights, and appliances. NM cable is typically easier to install than knob and tube wiring, and it offers improved safety features, such as a grounding conductor. Another common type of wiring used in residential buildings is armored cable, often referred to as BX cable. Armored cable consists of insulated conductors enclosed within a flexible metal sheath. It is often used in situations where the wiring needs to be protected from physical damage, such as in exposed locations or where it may be subject to abrasion. Conduit wiring is another method used in residential and commercial buildings. Conduit consists of metal or plastic tubing that is used to protect and route electrical conductors. Conduit wiring offers excellent protection from physical damage and moisture, and it is often used in industrial or commercial settings where these factors are a concern. When installing any type of electrical wiring, it is essential to follow all applicable electrical codes and regulations. These codes are designed to ensure the safety of electrical installations and to prevent electrical hazards. The National Electrical Code, or NEC, is a widely adopted set of standards for electrical installations in the United States. The NEC is updated every 3 years, and it provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical safety. In addition to the NEC, many local jurisdictions have their own electrical codes and regulations. These local codes may be more stringent than the NEC in some areas, and it is important to comply with all applicable requirements. When working with electricity, it is always important to prioritize safety. Firstly, always turn off the power to a circuit before working on it. This can be done by switching off the circuit breaker or removing the fuse that supplies power to the circuit. Secondly, use properly insulated tools and equipment. This will help to protect you from electrical shock. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. Fourthly, never work on electrical systems in wet or damp conditions. Water is a good conductor of electricity, and it can increase the risk of electrical shock. If you are not comfortable working with electricity, it is always best to hire a qualified electrician. Electricians have the training, experience, and equipment to perform electrical work safely and correctly. They can also ensure that your electrical system meets all applicable codes and regulations. Regarding specific sections of the National Electrical Code that might relate to knob and tube wiring, even though it's not typically installed in modern construction. Understanding these can provide context. Although the NEC doesn't explicitly detail knob and tube wiring in current editions for new installations since it's an obsolete method, it does have some information for existing installations in Chapter 3. Article 394, Concealed knob and tube wiring, provided specific requirements for knob and tube wiring when it was an accepted method. However, the current NEC mainly addresses the acceptable use of existing knob and tube wiring systems. Some relevant NEC sections that might apply to existing knob and tube systems are firstly, NEC 300.3b, which requires that all conductors of a circuit, including the neutral and equipment grounding conductor, be contained within the same raceway, cable, or cord. Knob and tube wiring, with its single conductors run separately, doesn't meet this requirement, which is why extensions to knob and tube systems are generally not permitted. Secondly, NEC 310.15b3, which discusses the allowable ampacities of conductors. Knob and tube wiring typically has lower ampacity ratings than modern wiring due to its insulation type and method of installation. Thirdly, NEC 310.15c, which covers conductor temperature ratings and their application. Ensuring that the terminations and devices used with knob and tube wiring are rated for the appropriate temperature is crucial. Fourthly, NEC 314.16, which deals with the number of conductors allowed in outlet device and junction boxes. When making any modifications or repairs to existing knob and tube systems, it's essential to ensure that the box fill requirements are met. Fifthly, NEC 406.3d, which addresses the replacement of receptacles. When replacing receptacles on grounded systems, such as those with knob and tube wiring, it's permitted to use a ground fault circuit interrupter receptacle, or GFCI, and label it No Equipment Ground. GFCI protection provides a level of safety against electrical shock. It's important to note that many jurisdictions have specific regulations regarding knob and tube wiring that may go beyond the NEC requirements. These local regulations may restrict the use of knob and tube wiring or require it to be replaced when a building undergoes renovation or is sold. Remember to always consult with a qualified electrician and local building officials before making any modifications or repairs to electrical systems, especially older systems like knob and tube wiring. Additionally, when evaluating the safety of older homes, consider the installation of arc fault circuit interrupters or SIs. SIs are designed to protect against fires caused by arcing faults in electrical wiring. They are more sensitive than traditional circuit breakers and can detect potentially dangerous arcing conditions before a fire starts. The NEC requires SIs in many new circuits, and it's a good idea to consider adding them to older homes as well, particularly in bedrooms and living areas. Another important aspect of electrical safety is proper grounding. A grounding system provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Modern electrical systems use a 3-wire system with a hot, neutral, and ground wire. The ground wire is connected to the metal enclosures of appliances and equipment, providing a safe path for fault current. Older homes with knob and tube wiring may not have a grounding system, which increases the risk of electrical shock. If you have an older home, it's a good idea to have a qualified electrician install a grounding system. This may involve running a ground wire from the main electrical panel to a grounding rod or water pipe. Even if you have a grounding system, it's important to test it periodically to ensure that it is working properly. A simple way to test a grounding system is to use a circuit tester, which can be plugged into an outlet to verify that the ground wire is properly connected. Regarding electrical panels, it's essential to ensure that the electrical panel is properly sized for the load it is serving. An undersized panel can become overloaded, leading to overheating and potentially a fire. The NEC provides guidelines for calculating the load on an electrical panel, and it's important to follow these guidelines to ensure that the panel is adequate. The electrical panel should also be properly labeled, with each circuit breaker or fuse clearly identified. This will make it easier to identify and shut off circuits when performing electrical work. Another important safety device is a surge protector. Surge protectors are designed to protect electronic equipment from voltage spikes, which can damage sensitive components. Voltage spikes can be caused by lightning strikes, power surges, or other electrical disturbances. Surge protectors are available in various forms, including whole-house surge protectors that are installed at the electrical panel and plug-in surge protectors that can be used with individual devices. Remember that electrical safety is an ongoing process. It's important to regularly inspect your electrical system, address any potential hazards, and follow safe practices when working with electricity. By taking these precautions, you can help to protect yourself, your family, and your home from electrical hazards. When dealing with aluminum wiring, which was used for a period in the late 1960s and early 1970s as a substitute for copper, special precautions are needed. Aluminum wiring can become loose at connections due to expansion and contraction, leading to overheating and fire hazards. If you have aluminum wiring, it's important to have it evaluated by a qualified electrician. There are several methods for mitigating the risks associated with aluminum wiring, including replacing the wiring with copper, using copolymer crimp connectors, or using special connectors designed for aluminum to copper connections. It's also crucial to ensure that any devices connected to aluminum wiring are rated for use with aluminum. In addition to these specific issues, it's always a good idea to have a general understanding of basic electrical principles. Voltage is the electrical potential difference between 2 points, measured in volts. Current is the flow of electrical charge, measured in amps. Resistance is the opposition to the flow of current, measured in ohms. These three quantities are related by Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. Understanding Ohm's law can help you to troubleshoot electrical problems and to select the correct wiring and components for your electrical system. Power is the rate at which electrical energy is used, measured in watts. Watts equals volts times amps. When selecting appliances and equipment, it's important to consider their power consumption to avoid overloading circuits. A 15-amp circuit at 120 volts, for example, can handle a maximum of 1800 watts. Knowing this limit is crucial for preventing overloads and ensuring electrical safety. Finally, remember to keep your electrical system in good repair. Replace any damaged or worn-out components promptly and have your electrical system inspected regularly by a qualified electrician. Electrical safety is not just a one-time effort but an ongoing commitment to protecting yourself and your property. Regular maintenance and awareness are key to preventing electrical hazards.